And you can think about blockchain really in the realm of cryptocurrency as a self-regulating digital ecosystem for value transfer. You have essentially periodically with Bitcoin every 10 minutes
Every day, trillions of dollars move through systems we never see. Banks, payment processors, and data centers, all run by middlemen we have to trust. If one of them makes a mistake, or worse, cheats, you usually never find out until it's too late. Blockchain flips that upside down. It's a public record book copied across thousands of computers and locked so securely that even a supercomputer would need centuries to alter a single line. In this video, we'll break down how blockchain really works, why it's considered tamper-proof, and how it's reshaping everything from money to supply chains. Picture a notebook page. Each line says who sent what to whom. When the page is full, you seal it with a special sticker. If anyone tries to tear it off, it's obvious the page was tampered with. Now photocopy that page thousands of times and hand it to strangers who stash it in their own safes. New page, same drill. Stack them and the stickers link the pages in order. Congrats, you just imagined a blockchain. The blocks are batches of transactions, the chain is the cryptographic glue, and the copies live on everyday computers called nodes. How does the sticker work? A math blender that turns any data into a short, unique fingerprint. Change one pixel and the fingerprint mutters, "Nope, never seen you before." Each block stores the previous block's fingerprint, so if a thief rewrites history, every later fingerprint shatters, domino style. Thousands of other computers notice something's wrong and refuse to accept the fake copy. That's why people say blockchain is immutable. Once the network agrees, the page is basically set in stone and can't be changed. So who gets to add the next page? That depends on the club rules, also known as a consensus mechanism. The original is proof of work, used by Bitcoin. It turns powerful computers called miners into competitive puzzle solvers. The first to solve a complex math puzzle gets to add the next block to the chain, and as a reward, they earn newly created coins. Others on the network then verify the solution in seconds, confirming the new block is valid. The proof-of-work puzzle race is what uses a lot of energy. A newer method, proof of stake, skips the energy marathon. Used by networks like Ethereum, it has validators lock up their own coins as collateral. One is chosen at random to propose the next page. If they cheat, their stake evaporates. There are other flavors, proof of authority, delegated proof of stake. But the goal's the same, getting thousands of strangers to agree on one history without a referee. No mining required to use the thing. Download a wallet, it quietly spits out two keys, a private one and a public one. Anyone can whip out your public key and verify the stamp, proving it came from you and arrived untouched. Lose your private key and no help desk can magic your money back. That's the glamorous part of being your own bank. Bitcoin made headlines, but the recipe can tag anything of value. Walmart traces mangoes. If E. coli pops up, the batch is nailed in seconds. De Beers logs every diamond's road trip, making blood gems tougher to slip through. Artists mint NFTs with royalty code baked in. Each resale auto sends them a cut. Estonia issues e-identities on blockchain, letting citizens vote or file taxes in slippers. These win because they swap closed systems for a shared timestamp no one owns. Think vending machine, money in, soda out, no cashier. Smart contracts are that logic living on the chain. Written as, if this, then that, they fire when conditions click. Ethereum made them famous, but Avalanche, Solana, and BSC host everything from on-chain insurance to decentralized exchanges. Blockchains aren't held together by goodwill, they run on incentives. Miners, stakers, and validators spend time, money, and electricity because they earn rewards. New coins, transaction fees, or both. That carrot keeps them honest because cheating would cost more than it pays. Tokenomics also sets the rules for scarcity. Bitcoin's 21 million cap, Ethereum's burn mechanism that can make it deflationary, stablecoins pegged to dollars. Good tokenomics balances supply and demand, so the network stays secure and the coin keeps its value. Bad tokenomics, that's when inflation spirals, rewards dry up, and a chain withers. So if code runs the logic, who runs the project? Enter the DAO, or Decentralized Autonomous Organization. Think of it as a group chat with a shared bank account. Proposals are made on-chain, let's donate to charity, or let's change the logo, and members vote with tokens. The rules are encoded in smart contracts, meaning no single CEO can run off with the treasury. It's an experiment in community-led governance, all happening in public. The blockchain is a closed system. It needs a secure messenger to bring in outside data. That messenger is an oracle. Oracles are services that find and verify real-world information, like weather data, stock prices, or sports scores, and feed it to the chain so smart contracts can act on it. To avoid trusting a single source, decentralized Oracle networks use multiple sources to agree on the truth. The other big challenge is speed. Bitcoin can only handle around 5 transactions per second, while Visa can process tens of thousands in the same time. That makes Bitcoin too slow for everyday things like buying coffee. To solve this, developers created Layer 2 solutions such as the Lightning Network, rollups, and sidechains. Think of these like express lanes on a highway. They handle lots of transactions quickly, group them together, and then send the final result back to the main blockchain for security. This way, small payments can be instant and cheap, while big, important transactions still rely on the slower but ultra-secure main chain. Not every blockchain is open to the entire world. Public blockchains, like Bitcoin or Ethereum, are permissionless, which means anyone can view the data, send transactions, or help validate them. But some organizations need more privacy. In that case, they use private or consortium blockchains, where only approved members can join. Imagine a group of banks teaming up to share a ledger. Only their computers can add or check transactions, keeping sensitive data hidden from outsiders. The trade-off is trust. With fewer participants, it's easier for a small group to cheat or censor data if they wanted to. That's why many companies use a hybrid approach. They keep the detailed data in their private network, but post a proof or timestamp on a public blockchain, so anyone can verify that nothing has been tampered with. This leads us to one of the biggest design challenges in blockchain, often called the blockchain trilemma. Picture a triangle with 3 corners: security, scalability, and decentralization. The problem is that it's very hard for a blockchain to be great at all 3 at the same time. Bitcoin, for example, is extremely secure and very decentralized, but that comes at the cost of speed. It can only handle a few transactions per second. Other blockchains can go much faster, but they often rely on fewer validators, meaning they sacrifice some decentralization. Developers are working on clever fixes to cheat this trade-off. Layer 2 solutions like the Lightning Network or rollups let most transactions happen off the main chain, but still rely on it for security. This way, you can get speed without giving up the safety or openness that make blockchains valuable. Blockchain doesn't magically make data correct. It just makes whatever everyone agrees on permanent. If wrong information goes in, it stays there forever. It's also not completely anonymous. Every transaction is time-stamped and linked in a public record, which is why law enforcement can trace stolen or illegal funds. And despite the hype, most businesses don't actually need a blockchain. If you already trust a central authority, like a bank or a company database, and don't need to share data with competitors, a regular database will be faster and cheaper. Blockchain makes sense when you need decentralization, a public audit trail, and a system that can't be taken down by a single point of failure. In the future, blockchain could change far more than just money. Imagine buying a tiny fraction of an apartment and trading it online anytime, just like a stock. Governments are exploring central bank digital currencies that could turn every dollar or euro into programmable money, so things like tax payments or stimulus checks could be sent instantly when you spend. Your health records could also become self-sovereign, meaning you control them. You could grant a doctor temporary access with a click, without giving insurance companies or hackers a permanent peek into your private data. The big idea here is shifting trust away from corporations and middlemen toward code that everyone can verify. We're still early. The technology, the laws, and the user experience are catching up. But adoption is growing fast and the momentum is only getting stronger. Not ready to risk a lot? Start small. Download a reputable crypto wallet and write down your seed phrase on paper. Never store it on your phone or computer. Then buy just a few dollars of a stablecoin. Use it to explore. Browse an NFT gallery, trade a few cents on a decentralized exchange, or send crypto between two of your own devices just to see how fast the confirmation shows up. Playing with just a few dollars is the quickest way to make blockchain feel real. And you'll learn more in 10 minutes of hands-on testing than in hours of reading. Let's recap. Blockchain groups transactions into blocks, links them with tamper-proof fingerprints, and copies them across thousands of computers. Instead of one referee, the network uses consensus rules to agree on what's true. Digital signatures prove who owns what, and once everyone agrees, the record is basically set in stone. Bitcoin proved the system works, but the real story is what comes next. Supply chains that track food in seconds, smart contracts that pay automatically, and digital identities you control yourself. The technology still has challenges. It needs to be faster, easier, and more energy efficient. But every month, it improves. Just like the internet changed how we share information, blockchain is changing how we share value and who we trust. Understand it now, and you won't just keep up with the future, you'll help build it.